Welcome back. The objectives of this video are to introduce the binomial theorem. We'll find some binomial coefficients. We'll learn how to expand a binomial, and we'll find a term of a particular binomial expansion. Our first objective here is to talk about binomial coefficients. Recall that a binomial is a polynomial that has two terms, and it's going to be raised to some particular power n. So here are several values of raising a binomial to a particular power n. Binomial to the 0 power is 1, the first power, the second, the third, the fourth, the fifth, and the sixth. Let's take a look at x plus y quantity raised to the fifth. If we look at our x values, or the first term in the binomial, we can see our x values, the exponents on those decrease by 1 as we continue through the expansion. So our exponents go from 5 to 4 to 3 to 2 to 1, and then finally in the last one we don't have any x at all because that's x to the 0 power. Conversely, the exponents on y increase. In our fifth power here, we don't have any y factor at all in the first term because that's y to the raised to the 0 power, which is 1, so we don't even show that. And then our y's begin to increase then as we go through the expansion. Y to the first, y to the second, y to the third, y to the fourth, and y to the fifth. Another thing you may want to notice is that our coefficient on the first and last term is always 1. And another thing you might notice is that the coefficient on our second term and our second last term is always the same as our exponent. So in x plus y to the fourth, we can see our coefficient on our second term is 4 and our second last term is 4. X plus y to the fifth, our coefficient on our second term is 5 and our second last term is 5. And then we'll show you how to find the other coefficient values. There are several observations you can make about these expansions. I think I've talked about most of those already, but they're listed here below. And I mentioned we will give you the formula to calculate the coefficients, but if you can at least get the first couple, the first two and the last two, you'll find that helpful. And I would definitely memorize how the exponents on the variables work, or how the exponents on the first term and the second term in the binomial. So here's our binomial theorem that the expansion of x plus y to the n. They kind of show here that our x's, we have x to the n plus n times x to the n minus 1 times y. So now our y's are showing up. So this is just a mathematical way to show, okay, our exponents are decreasing on x, or pardon me, they're decreasing on x, they're increasing on y, and that kind of thing. One thing to notice, our r is the exponent on y, our exponent on x is n minus r. That's going to be helpful for us. And this NCR business is the coefficient, and that's going back to my number theory or my counting class. I remember this as n choose r, and that n choose r, or n capital C subscript r, can be found by using this particular formula, n factorial divided by n minus r factorial times r factorial. And that can also be shown by this particular notation as well. NCR and n over r inside the parentheses are really the same. In our second objective here, finding binomial coefficients, we'll get a little practice here at using what I will call 8 choose 2. So we're going to use our formula that NCR equals n factorial all over n minus r factorial times r factorial. So for our first sample problem here, our n is 8 and our r is 2. So we have 8 factorial, all divided by 8 minus 2, or 6 factorial times 2 factorial. 8 factorial is just 8 times 7 times 6 factorial, all over, and I'm going to commutative property here and flip those two. The 6 factorials are going to cancel. 2 factorial is just 2. So 8 times 7 is 56 over 2, or that's going to simplify to 28. And 10 choose 3 is the exact same thing. This is the same as 10 choose 3. So we have 10 factorial over 7 factorial times 3 factorial. 10 factorial. So 10 factorial over 7 factorial times 3 factorial is 10 times 9 times 8 times 7 factorial, all over 3 factorial times 7 factorial. So my 7 factorials cancel. 3 factorial is 3 times 2 times 1. So 9 over 3 might simplify to 3 over 1. And 8 over 2 might simplify to 4 over 1. And if my arithmetic is correct here, I have 10 times 3 times 4 in my numerator. My denominator is 1, and I get 120. 7 choose 0 and 8 choose 8. I'm going to go down to our solution here and show how those work. So 7 choose 0 is 7 factorial over 7 factorial times 0 factorial. That's just going to simplify to 1. So anything choose 0, that's going to equal 1. And 8 choose 8, same kind of thing. We have 8 factorial over 0 factorial times 8 factorial. That is also going to equal 1. So let's take a look at expanding a binomial. It may be helpful to go back and look at our pattern for expanding the binomial theorem. We may be able to construct most of this ourselves. We have x plus 1 to the third power. So our x's are going to decrease. We're going to start with x cubed, x squared, x to the first, and then x to the 0, so I don't have any x here. The 1's are going to be easy to work with. On the left side, we have 1 to the 0, so there's no 1 here. And then 1 to the first, 1 to the second, and 1 to the third. That's kind of our y from our original problem. Our coefficients on the beginning and the end are going to be 1, and then their coefficients, the second coefficient is going to be 3, and the second last coefficient is going to be 3. So really, there's our answer. So I've got a whole bunch of factorials and stuff over here. Well, that's simply 3 choose 0 is the coefficient on the first term. 3 choose 1 is our coefficient on the second term. 3 choose 2 is our coefficient on the third term. And 3 choose 3 is our coefficient on the final term. So I've got those color-coded here. 3 choose 0 is 1, which is just in blue over here. 3 factorial over 3 factorial times 0 factorial. 3 choose 1 is in red. 3 factorial divided by 2 factorial times 1 factorial, which simplifies to 3. And then 3 choose 2 is over here in green. And we get 3 again, and then 3 choose 3 is just 1. We saw that on our sample problem. And we used our formula down here. Simplifying everything, we get our final expansion. Now, one thing to note here, to expand binomials with differences rather than sums, we would have alternating signs. So if this was x minus 1, we would have a positive, a negative, a positive, and a negative, that kind of thing. So we have a couple more sample problems here. We want to write the expansion of 2x minus 3 raised to the fourth power. So 2x might be a and 3 might be b. So our decreasing exponents are going to be the 2x term, and our increasing exponents are going to be on the 3. So let's take a look at how that might work. 2x to the fourth power, then 2x to the third, 2x to the second, 2x to the first, and then our last one we have 2x to the 0, which isn't even written there because that's just 1. And then on our y's, those are increasing. We start with y, or 3 to the 0, so it's not even here. And then our next term we have 3 to the first, and we have 3 to the second, 3 to the third, and 3 to the fourth. Our coefficients, we remember our pattern from earlier. Our first coefficient, our last coefficients are going to be 1, or 4 choose 0 and 4 choose 4. And our second coefficient is going to be our exponent, so that's going to be 4, and our second last coefficient is 4. And the only thing we really need to figure out then is the next one is this 4 choose 2. So putting that into our formula, we have 4 factorial over 2 factorial times 2 factorial. So to figure out this coefficient of 6, that's really 4 times 3 times 2 factorial all over 2 times 1 times 2 factorial. So those cancel, and 12 over 2 is 6. So our 6 came from that formula. So expanding this out, 2x to the fourth is 2 to the fourth. So 16x to the fourth times 1. And 2x quantity cubed was 8x cubed, but times 3 times 4. So 8 times 3 times 4 is 96. And our sign is minus, right? Plus, minus, plus, minus, plus. We'll have alternating signs. 2x quantity squared is 4x squared times 3 squared is 9. So 4 times 9 times 6. We get 216. And again, we have 4 times 2 times 27. Again, we get 216. And then 3 to the fourth is 81. So we have expanded that particular binomial. And in B, we do the same thing. We'll follow that same process. Our exponents on x start with 4. They go to 3, 2, 1, and 0. Our y's, 2y to the 0, so it doesn't even show up in the first term. And then 2y to the first, 2y to the second, 2y to the third, 2y to the fourth. Our signs alternate. Our coefficients, 1 on the beginning, 1 at the end, 4 on our second, and 4 on our second last. And since this is the same, it does make sense that we're going to get 6 again. We have to do some expansion and multiply this out. So 4 times 2, we get 8x cubed y. 4y squared times 6, 24x squared y squared. And 2y cubed is 8 times 4, we get 32. And then 16y to the fourth. So we've expanded that particular binomial. Our final objective, sometimes you will need to find a specific term in a binomial, and instead of writing out the entire expansion, which sometimes might be easier, you can use the binomial theorem, or from the binomial theorem, the fact that r plus 1th term can be represented by this formula. N, choose r, or our coefficient. Our exponent on x is n minus r, and our exponent on y is r. So if we want to find the 6th term of a plus 2b to the 8th, we're going to have 9 terms. There's one more term than there is exponent. And we want to find the 6th term, or the 6th coefficient. So if our first coefficient is 8 choose 0, then our 6th coefficient is going to be 8 choose 5. Our r is going to be 5. Okay, so that is going to be our r from our 6th coefficient, but our r is going to be 1 less than the term that we're looking for. That does make sense. That works out because r is usually the exponent on y. In the 6th term, our exponent on y is going to be 5. So that's why we have r to the 5th. In our 6th term, our coefficient, or our exponent on y, will be 5. Our n is 8, and in our problem, x is a, and 2b is y. and we want to find the sixth term. So using our formula, our coefficient is going to be n choose or 8 choose 5. So I've got that work over here. 8 factorial over 3 factorial times 5 factorial. Simplifying that, we get 56. A to the 8 minus 5, okay, is simply a cubed. And then our 2b is our y raised to the r, 2b to the fifth. We get 32b to the fifth. So putting this all together, we have 56 times 32b to the fifth times a cubed. And 56 times 32 is 1,792. And we have a cubed, b to the fifth, and this is then the sixth term. So we'll get a little bit more practice with binomial expansions when I see you in class.